Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving a nice cubic equation with complex numbers. We have z cubed plus 2z equals I, and we're going to be looking for z values. I have a feeling that we've done this problem or something similar before. If I did, I apologize. This is going to be a repeat, but maybe we didn't. If we did, let us know, and you can also compare these two videos, see how that goes. So I'll be presenting three methods. Maybe that's going to be different. Let's start with the first one. For my first method, I want to use the cubic formula because it's the most painful way to solve this problem, probably, right? So to use the cubic formula, I'm going to consider the following identity. A plus b cubed minus 3ab multiplied by a plus b equals a cubed plus b cubed. Nice. Now, if we assume that a plus b is equal to z, then we get an equation that is similar to ours. And obviously, z equals a plus b will be a solution of this equation. And if it's the same z, then a plus b will be z. Whatever we get from this equation will be a solution as well. I hope that makes sense. I've probably made it very confusing, but hopefully you get the idea. So from here, by looking at this equation, by the way, this is always going to look the same way. Now we can compare these two equations. Notice that the coefficient of z is 2 here. So 3ab, negative 3ab is 2, which means ab is equal to negative 2/3. And the constant term is I. So a cubed plus b cubed is equal to I. We're going to solve this as a system, and it's not cubic, it's quadratic. Let's go ahead and cube both sides here, maybe here. A cubed b cubed equals negative 8/27. Now we have a nice system. To solve it, I can go ahead and isolate b cubed from here. I can write it as I minus a cubed, and then substitute this here. So it'll look like this, a cubed times b cubed, which is I minus a cubed, equals negative 8/27. When you distribute everything and put everything on the right-hand side, you're going to get something like this. A to the 6th power minus IA cubed minus 8/27 equals 0. And we're going to use substitution one more time. Let's set A cubed equal to C because we are going to use B. So now this becomes C squared minus IC. Do you see what I see? Hopefully. Minus 8/27 equals 0. Since this is quadratic, and I already told you, right? It's not going to be cubic. It's going to be quadratic. We can use the quadratic formula because why not? So if you use the quadratic formula for this, you're going to get C equals negative B plus minus the square root of B squared, which is I squared, minus 4AC, that's going to be plus 32/27. Divided by 2a. I squared is negative 1. That's going to give us 5/27. So it's going to be like this. Plus minus 5/27 plus I divided by 2. Obviously, you want to simplify this a little bit maybe. Just multiply the top and the bottom by 27. So it'll be negative plus minus 5 plus 27I divided by 54. So that looks a little better than our original equation, doesn't it? And now what we need to do is we kind of need to, these are the C values, and C is A cubed or B cubed because they're interchangeable, right? So from here, by taking the cube roots of both sides, we get the values of A and B, and by adding them, we get the Z value. So this is what Z looks like. The cube root of negative 5, I'm just going to take the negative 5 first, plus 27I/54, and then plus the cube root of 5 plus 27I/54. Notice that 54 is 2 times 27, and you can easily cube root 27, but you're going to have a cube root of 2 at the bottom, which you need to deal with. Another thing is we need to cube root these numbers. How do you cube root those numbers? That's going to be pretty complicated. That's why this is the first method, brute force, super painful, forget about it. We're going to leave it at that, but at least I showed you one method. Let's go ahead and take a look at the second method, and you're going to let me know, right, which method you like the best. So we have z cubed plus 2z, or not 2z, minus I equals 0. Now, I noticed that my constant term is an I, and there's a chance that the solutions will be multiples of I, like imaginary numbers. So I'm going to replace z with ni. Now, this may or may not work. If it doesn't, that's fine. But if it does, icing on the cake. So if you replace z with ni, z cubed would be n cubed I cubed. But you got to remember, I cubed is negative I. So this will be negative n cubed I. Let's go ahead and plug it in and see what happens. Negative n cubed I plus 2ni minus I equals 0. You see, this makes sense because everything has I in it, and now we can go ahead and clear it. But let's go ahead and factor out a negative I here. We get n cubed minus 2n plus 1 equals 0. Obviously, we know that I does not equal 0, right? Hopefully you know that. By the way, if you don't know what it is, I squared is negative 1. In other words, I is the square root of negative 1. It's an imaginary number, which is the basis for complex numbers, and complex numbers are given as a plus bi. That's why the name of this channel is a plus bi. There's no other channel whose name is a plus bi. This is unique, right? And if you're new to complex numbers, go ahead and check out my lecture videos. If you like algebra, number theory, go ahead and check out cyber math, cyber with an S. So let's go ahead and focus on this now. Since I does not equal 0, this should be 0, which means n cubed minus 2n plus 1 is equal to 0. Now, how is this easier than the original equation, right? It's very similar. Well, guess what? We don't have any imaginary coefficients. Everything is integers. Plus, this is a special polynomial. Why? If you couldn't tell, you've probably seen some of my earlier videos. I always talk about it. The sum of the coefficients is 0. Don't ever forget that. That's the very first thing you should check if you have a polynomial equation. So, n equals 1 is a solution. Notice that 1 plus 1 is 2. 2 minus 2 is 0. So we can factor this. You can do polynomial division, synthetic division, artificial division. I don't think there's something like that. Artificial intelligence, whatever. Or you can just manipulate like this. N cubed minus n squared plus, I was supposed to do n squared. N cubed minus n squared plus n squared minus n plus 1 equals 0. Notice that I kind of played with the numbers to get factors of n minus 1, because if n equals 1 is a solution, by factor theorem, n minus 1 is a factor. Nice. Now we can go ahead and factor this n squared times n minus 1 plus n times n minus 1 minus 1 times n minus 1 equals 0. And once you factor out n minus 1, which gives us n equals 1, we already know that, right? Well, probably. We're going to get all the solutions. So we're not looking for n though, be careful. We're looking for z. If n is 1, and since z is ni, right? Did we say that somewhere? Yeah. Z is ni. So from here, z is just going to be I. Is I a solution? Yep. I cubed plus 2i minus I. I cubed is negative I, negative 2i, I, 0. You get the idea? Okay, hopefully. So that's one of the solutions. But there are other solutions that come from the quadratic. And do you smell the golden ratio? I hope so. So n becomes negative 1 plus minus the square root of b squared minus 4ac, which is 5. This number should look familiar. So from here, we get two n values, but let's go ahead and write them z. Write the z values. Negative 1 plus root 5 over 2 multiplied by I. And then the third solution is negative 1 minus root 5 over 2 multiplied by I. So we have three solutions because this is a cubic equation. As you can see, all solutions are imaginary. We're just imagining them. They don't exist, right? Well, I guess complex numbers are as real numbers. So third method. The third method kind of uses a similar trick, but without reverting this to integers. So here's what I notice. I can write this as z cubed plus I plus 2z minus 2i equals 0. Why? You might be questioning. Because I cubed is negative I is negative I cubed. So I can now write it as z cubed minus I cubed, and I can factor out a 2 here. And guess what? We could use difference of two cubes. How nice is that? Z minus I, Z squared plus IZ plus I squared plus 2 times Z minus I. Hopefully you get the idea, right? I get the idea. I get the idea. Z minus I, and then you get, this is -1 by the way, so you get Z squared plus IZ minus 1 plus 2, that will be plus 1 equals 0. And if you solve, you're going to get the exact same solutions. Do you think Wolfram Alpha can handle this problem? Of course, right? It can't handle all the problems, but it can handle this problem because this is fairly easy to do, right? And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.